Hey children, so I noticed that while we're doing these stations, sometimes you guys aren't getting the most help that you need once you leave my notes section and start to practicing on your own without me. And so, if there's a problem, we look for a solution. So I'm going to see if maybe doing the notes like this on a video and then me, myself, working with you while you practice will maybe help us out a little bit. Okay? So what we're talking about today is quadratic graphs and specifically how they are symmetric. Okay, symmetric means that one half of the graph is going to be a mirror image of the other half of the graph. Okay, so there's a couple of key things that you need to know about quadratic graphs, and the first one is called roots. Sometimes it's also called zeros. Essentially what they're talking about, Essentially what they're talking about is the x-intercepts. So go ahead, write x-intercepts. Now these x-intercepts are also sometimes called solutions. Okay. Now when I think about y-intercepts, I know y-intercepts happen when the graph intersects the y-axis. So we should know that the x-intercepts happen when the graph intersects the x-axis. So if I'm looking at this graph here, right down here where it has the x, that's my x-axis. So if I'm looking here, I can see, oh, it crosses here, and it also crosses here. So on my graph, I'm going to put 2 points there, like that. Go ahead, put those 2 points on your graph. And I'm also going to write down what those points are because they're important to this graph. -2 for x and 0 for y, and 0 for x and 0 for y. So you'll see that something that these two have in common is that the y's are 0, okay? That's actually always going to happen when you have an x-intercept. The y should be 0 because x-intercepts are the values of x that will make your equation equal 0. Go ahead, write these in this box here. Take a moment now. In the second graph, I want you to put points on where you think the x-intercepts are, and make sure to write down the points, and then to also write the points down here in the box. You can go ahead, pause the video right now, do that, and when you're ready, come back and check what I've done. So hopefully you've put points here, and these 2 points actually for this problem, by coincidence, end up being the same 2 points that we used on the other part. So you should have -2, 0, and 0, 0. Okay, so those are the x-intercepts. That's one important part about these graphs. Another thing that we're learning today, this is actually a new term for you, is called the axis of symmetry. Okay, now the axis of symmetry is just like the x and the y-axis. It's a line. It's a line that is vertical. Okay, so the axis of symmetry is a vertical line that splits a parabola, so each side is a mirror image. Okay, I want you to go ahead. I know I can't see you, but I'm going to assume you're doing this. On your graph, please put your finger where you think the middle of the parabola is. Okay, so I identify the middle being right here. And if I go up and down, I see, oh, if this was a vertical line here, it would split my parabola in half so that the left side was a mirror image of the right side. Okay, this is what we call the axis of symmetry. So go ahead, and we're going to draw a straight solid line here, straight solid vertical line here. And mine's kind of off center, but I'm going to leave it there to save time. And we're going to actually label this axis of symmetry. I'm going to abbreviate that. Now, I want you to think about this. If I had to write an equation of this line, okay, this is a vertical line, and what I know about this vertical line is that all the points on here have the same x value. What is the x value that all of the points on this line would have? Well, if I examine it, this is x is -1 and y is 0. This is x is -1 and y is 1. This is x is -1 and y is 2. So this lets me know that x is always -1. So the equation should be x equals -1. And I go ahead and I write that down, x equals -1. Write that down inside of my box. And now go ahead, take a chance to go ahead, look at this second graph and try to identify what the axis of symmetry is. So draw your line, write down what you think the equation is. You can go ahead and pause this video now because I'm about to tell you how to do it. So once you've gotten it done, unpause it so you can see if you've got the same thing I did. The axis of symmetry on this graph is right here, going down the center. So that's a mirror image on both sides. And again, I would still label it axis of symmetry. And if we look at the x values here, again, by coincidence, this is also x equals -1. Okay, so that handles two of the most important parts of this. The next thing we're going to look at are called points of symmetry. So, points of symmetry, that's what's going to go here. Points of symmetry are points on the parabola that are mirror images of each other. So what that means is that they are directly across from each other on the parabola. So if I take a look at this first graph, pretty much any points that are directly across from each other are are points of symmetry. Okay? The axis, the middle, is in the absolute middle of them. So I know this point is symmetric to this point. But obviously these are not clear points, so I can't say what they are. So we're just going to list the clear points that are points of symmetry. If you see in this graph, these 2 points are actually the only 2 points that we have that are points of symmetry. So I'm going to write those down for my points of symmetry. That was -2, 0, and 0, 0. Okay, now let's take a look at this second graph, because there are more than actually 2 points that are points of symmetry. I do notice that these 2 are points of symmetry, but if I keep looking on my graph, I can actually find another set of clear points right here that are also points of symmetry. They are symmetric from each other across the axis of symmetry, which is the mirror. Okay, so I could put points here. I'll actually use a different color here. I can put points here and here. These would be another set of points of symmetry. So in this graph, I actually can see 2 pairs. So I'm going to write down both of those pairs. So one of the pairs was the same as the last one, -2, 0, and 0, 0. And then the second pair was -3, -6, and 1, 6, -6. So if you see here, what they have in common is that y value. That's what keeps them being symmetric, keeps them across from each other. Okay. Now this next part is going to be something very important. It's called the vertex. Now the vertex is a very, very, very special point when we're talking about quadratic equations and when we're talking about a parabola specifically. Okay. And that is because the vertex is the point It's the point of the quadratic function that lives on the axis of symmetry. So it lives on the axis of symmetry, which means that this is actually the very most middle point of the graph that we have. So if I look up at my graphs, or if you look at your graphs, you can go ahead and point at whatever point you think is the vertex. Hopefully this is the point that you're looking at. So as I can see, it's on my graph, the parabola, and it's also on my axis of symmetry, which goes up and down. So it's where those two meet. The vertex is a special point that lives on the axis of symmetry. The vertex is a special point that lives on the axis of symmetry. So for us, our special point would be right here. And I can go ahead and even label it. I'm going to put the point there. I'm going to write vertex. Make sure you're doing this as well. Put your point and write vertex. And then go ahead and write down the coordinates of this point. What are the coordinates of this point? Well, x is -1 and y is -2. And what you'll see here is that the x value is -1, just like our axis of symmetry. And that makes sense because it lives on the axis of symmetry. It is a point on this line, so of course it's going to have the same x value. Now we can come back down to our vertex box, and we can write our point that we found, which is -1, -2. Go ahead, try to identify the vertex in the second graph, label it, and write it down in your box. I would say go ahead, pause this video and do that so that when you unpause it, you can check to see if you're right. Hopefully you put that the vertex point is right here, vertex, and this point is actually -1, +2. I'm also hoping that you wrote it down in the box as you were instructed. Okay, we're coming down to the final two important things about this before you get to practice, maybe with me or maybe without me, whatever you feel most comfortable with at this moment. Okay, so the next thing is that even though we don't have any equations up here, the graphs by themselves can actually tell us something very important about the equation, and that is what the leading coefficient is. Okay, so the leading coefficient is a special way to describe the first number that comes in front of x squared in your quadratic equation. So essentially they're talking about a. So in this box we're going to write the leading coefficient. Okay. Now the leading coefficient will determine if your parabola opens up or down. Okay. Now just a reminder, when we have a quadratic equation, it's usually of the form ax squared plus bx plus c. Now, the leading coefficient, again, is a fancy way of saying the number in front of x squared. So we're ideally just talking about a. Okay. Now the way that a affects our quadratic equation is it tells us if our parabola opens up or if it opens down. And the way it does that is with the sign that the a value has. For example, if a is positive, then our parabola opens up. If it's positive, our parabola opens up. But if a is negative, then our parabola opens down. Again, if a is negative, the parabola opens down. So if I look up at this first graph that we have, would you say that this graph is opening up or opening down? One way that I used to remember it is that up has a u in it, and it looks like that. Okay, opening down has an n in it, and it looks like that. Looks like the n in down, or it looks like the u in up. So this first graph actually looks like the u in up, so I know this parabola is opening up. Since this parabola is opening up, then we know that a must be positive, or else how would our parabola open upwards? So for my answer in this box, I would write a must be positive because parabola opens up. Go ahead, write what you think would be our answer for the second graph. And then hopefully it matches what I decide to write. What I notice about the second graph is that it opens down. So since it opens down, I know that a must be negative. Okay, so now we're going to come to the final part which is not difficult, but some people find it tricky on figuring out how to write the answer. Okay, so I'm going to try to make it a little simple for us. So the final part has to deal with where our graph is increasing and where our graph is decreasing. Okay, so you can describe where a graph is increasing or decreasing using intervals. Okay, now an interval is a way to describe a range of numbers, and it actually looks like a coordinate point, but it's not a coordinate point. So when I first learned this, it was pretty confusing for me because I thought it meant a point, when really it meant a range of values, a range of x values in our case specifically. So I'm going to tell you how to notate that so you can get it into your brain. Oh, I'm talking about a range of numbers, not just one point. Okay, but first we have to be able to analyze our graph and decide where it's increasing and where it's decreasing. Okay, it's important to remember that with a quadratic function, it is always both increasing and decreasing somewhere on the graph. So if I look up at my first graph, remember that we read graphs from left to right. So I should be starting at the leftmost point of my graph, which would be here. Now, as I'm moving in the x direction to the right, I can see that my graph is going down, which means that my graph is decreasing. Now, once I get to this point, my graph stops decreasing. If I continue to move to the right, I can see that in order to stay on my graph, I must increase. So now I've seen two things. On this side, I'm decreasing, but on this side, I'm increasing. And the middle part that separates it is actually my axis of symmetry. Okay, so I'm going to use that information to try to figure out exactly how I'm going to use intervals to represent this. So if we come back down to our box, this is what I want you to do. So in your box, I want you to first draw a line. Draw as straight as you can line going across here. And we're going to use this kind of like a number line. Okay, I know the part of my graph where it changed was at -1. So I know on the left side something was happening, and on the right side something different was happening. So if we slide back up to our graph pretty quickly, on the left-hand side of the axis of symmetry, our graph is, that's right, it's decreasing. But on the right-hand side, our graph is increasing. So if I come down here, I know that on the left-hand side, it's decreasing. So write that down. And I know on the right-hand side, it's increasing. Okay. So what this means is that for the x values, all of the x values before -1, I'm decreasing. And all of the x values after -1, I'm increasing. Well, if I want all of the x values, and I keep going in this direction, well, the numbers never end, which means I can't put a final number here, but what I can say is that this is positive infinity on this side, which means that my x's go on forever. Okay? I can also do the same thing on the left side, but on the left side I don't have positive numbers. What kind of numbers do I have on the left side? Negative numbers. So I wouldn't put positive infinity, I would put negative infinity. Okay? So now this is where the interval notation comes from. Okay? Again, I told you it looks like points, but it's not points. So we're going to write two parentheses just like this. And just so I know it's not points, we're going to put arrows under them. Because what this really means is that I'm going to go from this value for x to this value for x. And I'm going to go to this value for x, from this value for x to this value for x. So if I'm looking at where I'm decreasing specifically, I know I can go from negative infinity all the way into -1. So I would write negative infinity to -1. So this shows the range of values for x where my graph is decreasing. Now for increasing, I would go from -1 till positive infinity, which means any numbers that are larger than -1 that exist at all because it goes to positive infinity, my graph would be increasing. My graph would be going up as I move to the right. So this means, again, as I move to the right, up until -1, I'm going down. After -1, as I move to the right, my graph is going up. Okay, go ahead, analyze the second graph. Write down what you think these intervals would be for that second graph. I suggest you pause the video and come back when you're done so you can check if you got what I got. Okay, so let's take a look at this. This graph is a bit different because instead of being a U, it's actually an N. But that doesn't mean that the way that we write down the intervals is any different. So again, we start with our number line. We know that the spout that it changes is -1. We also know that on the left side, it's increasing. And on the right side, it's decreasing. I also know that if it goes on forever to the right, that positive infinity is on that side. And if it goes to the left forever, that's negative infinity. And then I write my intervals. I know that I'm increasing from negative infinity until -1. And I know that we're decreasing from -1 until positive infinity. So that means between these x values, my graph is going up. And between these x values, my graph is going down. Okay? If you look at the next page of your notes, this page here, you have 3 graphs for which you can practice by yourself. So as of right now, you probably only have 3 or 4 minutes left, but I would suggest that you try to do something so that when you come to me in the next station, I have something to help you with, or maybe some questions that I can answer for you. Okay? Thank you for following the notes. Hopefully you did your best to stay on task and stay concentrated. I know it's not the most fun thing to watch a video, but I do think it's going to help us in the long run. Okay? See you in a few minutes, kids.